Section 8.2, Arithmetic Sequences and Partial Sums. Section 8.2 focuses on a specific type of sequence now, an arithmetic sequence. What makes a sequence arithmetic is the difference between consecutive terms is the same, and that difference is called the common difference. The nth term of an arithmetic sequence is given by a of n equals dn plus c, where c is the first term minus d, d is the common difference, n is the term number. So you're going to see a lot of the same terminology that we talked about in the first section. You have to understand the terminology and what it is telling you. Using a recursion formula, our final formula that you will be using over and over and over again in this section is right there. The nth term, remember a of n represents the nth term, so some specific term is equal to a of 1, which is the first term, plus n minus 1 times d. We know n is the term number, d is the common difference. Now, the key here to this formula is you do not necessarily have to know this first term. The first term is given right there in this formula because of what we have right here. This n minus 1 is n minus 1 because this is the nth term here. This is the first term here. Therefore, we do n minus 1 in here. If you are not given the first term and you're given any two other terms, you do not have to find the first term in order to be able to use this formula. Let's say that we were given the 15th term and we were given the 4th term. You can plug in whatever two term values you want to in place of a of n and a of 1. The only thing you need to make sure is now in the formula, what goes in the parentheses here is not necessarily always going to be n minus 1. It's going to be this term number minus this term number. So in this case, it would be 15 minus 4 times the common difference. Term values go in here and here. The term numbers associated with those values always go in the parentheses. So you can keep that in mind. This formula is very, very easy to use. Looking at some arithmetic sequences. First one here, you can clearly see that we are adding 4 each time. 7 plus 4 is 11, 11 plus 4 is 15, and so on. The nth term is defined by 4n plus 3. In other words, if we plug 1 in here, 4 times 1 is 4, plus 3 is 7. Plug 2 in here. 8 plus 3 is 11. That's how we can get each of the terms. Second one, 2, negative 3, negative 8. We can clearly see that we are adding a negative 5 here each time. That's what makes it arithmetic, is because we're adding the same thing every single time. Our nth term is defined as 7 minus 5n. Put 1 in, 7 minus 5 is 2. Put 2 in, 7 minus 10 is negative 3, and so on. Third one, 1 5/4, 3 halves. Not quite as easy to see the common difference here because we're dealing with fractions, but our common difference is 1/4. If I take 1 plus a fourth, I get 5/4. 5/4 plus a fourth is 6/4, or 3 halves, and so on. Our nth term is defined to be 1/4 times n plus 3. Find the nth term of an arithmetic sequence whose common difference is 3 and whose first term is 2. Go to your formula. A of n equals a of 1 plus n minus 1 times d. Plug in what we know. We're looking for the nth term, so we don't know that. We know the first term is 2. So in our parentheses here, n minus 1, nth term minus first term, that's going to stay as n minus 1, and we're told the common difference is 3. Simplify this formula, and you're done. Distribute the 3. We get our nth term to be 3n minus 1. Example 2. Fourth term of an arithmetic sequence is 20. 13th term is 65. Write the first 4 terms. So I would begin by writing down what you know. You know the fourth term, or a of 4, is 20. You know the 13th term, is 65. We want to know what are the first four terms. Well, in order to do that, we need to know what our common difference is. So let's go to our formula. A of n equals a of 1 plus n minus 1 times d. Plug in the higher term number that you know. In other words, we know the 13th term. We can put that in right here. We know the fourth term. We can put that in right here, but now this isn't going to be n minus 1. It's going to be this term number, which is term 13, minus this term number, which is term 4. And now we can solve this to find d. 65 equals 20 plus 9d. Subtract the 20 over. Our common difference is going to be 5. Common difference is positive, which we can see 20, and we're adding to get up to 65 at some point. So a couple different ways now we can write the first four terms. I already know the fourth term is 20. So I can subtract 5 if I want to get terms before this. 15, 10, 5. There are the first four terms of the sequence. If you don't recognize that, you could always go back to your original formula. A of n equals a of 1 plus n minus 1 times d, and plug in. We know the fourth term in this case is 20. We don't know the first term, so in parentheses it's term 4 minus term 1. Common difference we just found to be 5. Subtract the 15, and we can see that the first term has to be 5, so you could start it with 5 and then add the common difference as well to get each of those first four terms. Third one, find the seventh term of the arithmetic sequence whose first two terms are 2 and 9. So we know 2, 9, and then we want to find all the way out here what that seventh term is equal to. Now, for this one, it would not be too bad to simply take 9 plus 7. There's the third term, plus 7 more. There's the fourth term. But if this said find the 77th term, you would not want to do that. So let's go to our formula. A of n equals a of 1 plus n minus 1 times d. What are we looking for? The seventh term. Do we know the first term? Yes. So in parentheses, it is going to be 7 minus 1 because those are the two terms we're using. We know the common difference here is 7 because 2 plus 7 equals 9. So our first term was 2. Common difference is 7. 2 plus 6 times 7. 2 plus 42, our seventh term is going to be 44.